Hi everyone, in this video we are going to discuss about how to calculate the trigonometric ratios of angles like 180 degree plus theta. So that's like a reflex angle, and we are going to calculate the trigonometric ratios of such angles in terms of the trigonometric ratio of our base angle theta. We are taking theta as our base angle or our acute angle theta, and we'll try to express the trigonometric ratios of 180 degree plus theta in terms of the trigonometric ratios of theta angle. Right? So from our concept of unit circle and the concept of trigonometric functions like the sine function and the cosine function, we know that if we have a point P on a unit circle, then the x coordinate of the point P will be represented by cosine of theta, where theta is the angle that OP creates with the positive x-axis, and similarly the y coordinate will be represented by the sine of theta, and those are the sine and cosine functions. So the x coordinate is represented by the cosine function of theta angle, and the y coordinate would be represented by the sine function of theta angle. So using theta as our acute angle, we are going to now calculate the trigonometric ratios of 180 degree plus theta. So what I am going to do next, I am going to plot a point Q on this unit circle where the OQ radius will create an angle 180 degree plus theta with the positive x-axis. So let me first plot the point Q. So here I have plotted the point Q where OQ creates an angle 180 degree plus theta with the positive x-axis. So here in the diagram, as you can see, there are two little triangles that I have drawn. One triangle is the OAP and the other triangle is the OBQ. And if you look at these two triangles, they are obviously right triangle because I have dropped a perpendicular from P onto the positive x-axis, and also I have dropped a perpendicular from Q onto the negative y-axis. So those are perpendicular, that means those are right angles right there. So these are actually right angles. And also the angle BOQ and the angle AOP, they are actually vertical angles. They are vertically opposite angles, so they will be equal. And then obviously the angle BOQ will be equal to theta. And also if you think about the angle APO and the angle BQO, they also will be equal because they all will be 90 degree minus theta. They will be the complementary angle of theta, right? So we have these two triangles where the hypotenuse length is equal because it's the radius of this unit circle, and then all other angles are equal. Using the angle side angle axiom of congruent triangle, we can say that these two triangles are congruent triangles. So can we write it like this? And because the two triangles are congruent, their corresponding side lengths will also be equal. So from here we can say OA must be equal to OB, and similarly we can say that AP will be equal to BQ. So now let's try to find out the cosine of 180 degree plus theta. That is actually the x coordinate of the point Q, right? So let me write it like this. And what is the x coordinate of Q? Well, that is actually the length OB, but again we have to consider the negative sign because the x coordinate here will be along the negative x-axis because the point Q is on the third quadrant. So we have to take negative of OB. So I can say negative of the length OB. I am using a modulus sign here or the absolute value sign to indicate that we are taking just the length of OB with a negative sign outside because point Q is in the third quadrant and its x coordinate should be negative. And now what is OB? Well, as you can see, OB is actually equal to OA. So can we write it like this? It would be negative of OA. And then what is OA? Well, as you can see, OA is equal to cosine of theta, as I have noted up there in white color. So here, can we write it like negative of cosine of theta? So we have been able to find the value of cosine of 180 degree plus theta. That turns out to be negative of cosine of theta. So let's also populate the x coordinate of Q here. I have left an empty parenthesis here. I have not written anything yet, but I am going to populate the x coordinate of Q. Now what is the x coordinate of Q then? Well, x coordinate of Q is negative cosine of theta, and again cosine of theta is equal to x, so this will be negative of x. So we can write it here as negative of x. Now let's make a quick note here. Similarly, let's try to calculate the sine of 180 degree plus theta. And sine of 180 degree plus theta will actually be the y coordinate of the point Q. And if you think about it, the y coordinate is also negative here because the point Q is in the third quadrant, and this y coordinate will be negative of the length BQ. So we can write it as negative of modulus BQ. Now what is BQ? Well, BQ is actually equal to AP right here, as you see in my note, green underline here. So BQ is equal to AP. So can we write it as negative of AP? And what is AP? Well, as you can see up up there AP is actually equal to sine of theta. So AP is actually sine of theta. So here we can say, okay, this will be negative of sine of theta. So we have been able to calculate the value of sine of 180 degree plus theta, which is actually equal to negative of sine of theta. So let me make a quick note here. Also, let's try to populate the y coordinate of q. Well, y coordinate of q is actually negative of the BQ length, and BQ length is nothing but the AP length. It's same as the AP length, which is the y. So it will be negative of y. So the y coordinate would be negative of y. So here I now wrote that the y coordinate of q is negative of y. So q's coordinates are now negative of x and negative of y. So if you know the coordinates of p, then you can easily figure out the coordinates of q. And because theta is an acute angle, we already know the trigonometric ratios of standard acute angles, and using that knowledge we can easily calculate the trigonometric ratios of angles like 180 degree plus theta. So now let's calculate the tangent of 180 degree plus theta. We know that tangent is the ratio of sine over cosine. Now what is the value of sine of 180 degree plus theta? Well, that is actually negative of sine theta. And then what is the value of cosine of 180 degree plus theta? That is actually negative of cosine of theta. Now the negative and negative in the numerator and denominator, they will cancel out each other. They will become positive. So finally we would get positive of sine over cosine, that would be tangent. So this should be positive tangent of theta. So let me make a quick note. Now let's calculate the remaining trigonometric ratios for this angle. So next we are going to calculate the cosecant of 180 degree plus theta. Cosecant is the reciprocal of sine, so we can write it like 1 divided by sine of 180 degree plus theta. And then what is the value of sine of 180 degree plus theta? Well, that is actually negative sine of theta. So here we get a negative value, and reciprocal of sine of theta would be cosecant of theta. So let's make a quick note. Now let's calculate the secant of 180 degree plus theta. We know that secant is the reciprocal of cosine, so we can write it as, and what is the value of cosine of 180 degree plus theta? That is actually negative cosine of theta. So this is now equal to 1 divided by negative cosine of theta. So we get a negative value, and the reciprocal of cosine is actually secant. So this is actually negative of secant of theta. So let's make a quick note. And now we are left with the last one, which is the cotangent of 180 degree plus theta. So let's derive that. We know that cotangent is the ratio of cosine over sine. So we can write it as cosine of 180 degree plus theta divided by sine of 180 degree plus theta. Now what is the value of cosine of 180 degree plus theta? Well, that is actually negative of cosine of theta. And then what is the value of sine of 180 degree plus theta? That is again negative of sine of theta. We have already derived these two values at the beginning. So here cosine of 180 degree plus theta is equal to negative of cosine of theta. Similarly, sine of 180 degree plus theta is equal to negative of sine of theta. So using those two values, now here we can say that this is now going to be equal to a positive value, because the negative in the numerator and the denominator, they will cancel out each other. So we are going to be left with a positive value. Now ratio of cosine over sine, that is actually cotangent. So this will be positive cotangent of theta. So let's make a quick note. So we have been able to calculate all of the trigonometric ratios of 180 degree plus theta in terms of the trigonometric ratios of the theta angle, which is our base acute angle. Hope everything made sense. Thank you for watching. See you in the next video.